Hello and welcome to the lesson on ratios and proportions. So ratios and proportions is a topic that we talked about last year in grade 9. Very important topic. It continues into the grade 10 course, so we are going to revisit it today. The learning goal, I can explain ratios and proportions and apply it to real world situations. So let's just go back to basics here and let's remember or remind ourselves what is a ratio. So our definition then is a ratio is a comparison of two quantities. All right. So ratios, for example, then can be written in the form A to B, and that colon there, that is our ratio notation, if you recall. So what is an example of comparing it to two quantities? So the examples we can use, for example, would be, say, boys to girls in the class. That would be a comparison of two quantities. It could also be something like cups to planets, for example. So it doesn't have to be even in the realm of seemingly related, but what it is just a proportion. It's setting us up as to know how many of one, then how many of the other can we expect. So as we move on to the the greater application here is what is a proportion. We find that a proportion is a comparison of two ratios. Ratios. So what does that look like? So basically we're ending up with one ratio, so A to B, and we're setting equal to another ratio, say D to F, where the ratios match up in that the first term is a measurement of the same value, and the second terms also line up. So using one of our examples then, if we were talking about boys to girls, so this could be boys to girls in our class. If we were to make a comparison then, we could do boys to girls in the school. So it still lines up. If you notice, the boys still line up as our first part of each ratio, and the girls are the second part of each ratio. So it's very, very important that these two parts of the ratios line up because it allows us to keep that balance. So there is what is exactly our proportion. So some examples that you're going to work your way through this in the homework. I'll give you a couple here and we'll work through them together and we'll remind each other how to go through it. So if I have the example of 4 to 5 and that's equal to, let's go with 12 to blank. So what we do, just as a quick reminder, are steps. First step is, what we do is we take the isolated number, so the number that's by itself. So we take the number by itself, or that's by itself, or that's alone, and we divide it by its partner, or by its matching term. So the 12 was the first term in the ratio, so its matching partner is the 4. So our first step then is to do the 12 and we divide by 4. That gives us a value of 3. Step 2 is then to take our answer, and multiply by the remaining number or numbers. Oops. So we would take our answer, that's 3, and we're going to multiply by our remaining number, which is our 5. So we would multiply it by 5, and we would get 15. So our answer then up in the ratio would be 15. So there's our answer to that particular one. All right, so as we move through, we'll do a second example here. If I do 7 to 30 is equal to blank, to, let's go with 90, then the process down below here. So step 1, take the number that's by itself, so the 90, we divide it by its partner, so it's the second term, its partner will be the second term from the other ratio, so 90 divided by 30 will give us 3. We take, in the next stage, take that value and we multiply it by the number that's left, so the 7, so 3 times 7 is 21, and that is our missing value in the ratio. Okay, we might end up with a 3-term ratio. So if we go 1 to 9 to 15 is equal to blank to blank to, we'll go 45. We see that we now have 3 terms in our ratio. So 1, 2, 3. We're missing the 1 from this one, missing 2 from that one, missing 3 from that one. We do have 2 matching ones, the 3. So that is our first stage. So we'll take the one that's by itself, the 45, and we're going to divide by 15. And again, we get 3. Seems to be a common theme for me here. And now we have 2 numbers that we need to multiply by. So we take each of them and multiply them by that 3. So we do 1 times 3 is 3. We also do 9 times 3, gives us 27. And those become the missing values or the answers to our proportion. So it's the same process over and over for us when we're going through that particular process when we're solving for a proportion or an unknown in the proportion. So I have an example here, word problem, typical to what you're going to have on the assessment. So a soil mixture has sand, peat, moss, and loam, and it gives us a ratio. It gives us the 2 to 9 to 4. So what we have here is part of our answer. So if I go down here, and I'm not even looking at what A is, but I know I have a ratio of 2 to 9 to 4, and that's in the order of sand, peat, and loam. So we're going to answer the following. How much is in a 400 kilogram bag? Well, 400 kilograms is a total. So as I said before, these ratios can represent whatever we want them to represent. So in this case, I'm going to have those ratios represent kilograms. So that would mean that when we're looking at our 3-term ratio here, if I put 2 kilograms of sand, 9 kilograms of peat, 4 kilograms of loam, I'm going to end up with 15 kilograms in total. So that's where the T comes from. So I'll have an unknown, because now I have a 4-term ratio, but I know the total amount is going to add up to 400. And I have sand, peat, and loam. Now I just want to know how much loam for A part. So I'm really just looking for this value right here. So how do we solve it? Same steps as we did on the previous slide. I take the number that's by itself, so the 400. So 400, and I'm going to divide it by its matching term, which is the 15. So I need to do 400 divided by 15. And we end up with 26.67. So 26.67 26.67. Step 2 then, we multiply all the numbers by, but we're only looking for loam. Loam is 4. So we take our answer that we just got, 26.67. We're going to multiply it by 4. And we use the calculator to get that. So times 4, we get 106.7. So 106.7, 106.7. And that's the answer that goes right in there. So therefore, we need 106.7 kilograms for 400 kilograms, or for a 400 kilogram bag. All right. Now, the question B then is, what percentage of the mixture is loam? So this is practicing, going back and practicing our percentage. So for B part, remember our percentage is how much we have. So we have the 106.7 over the total. Well, we know there's 400 kilograms in the bag. We're going to multiply that answer by 100 to get our percentage. So using our calculator, oops, lost my calculator. So just clear that. So I do the 106.7. I'm going to divide it by 400. To get it to a percentage, I need to multiply by 100. And we get 26.7%. So we find that 26.7% of the mixture is loam. So therefore, 26.7% of the bag is loam. And there you go. So just keep in mind when you're going through and going through these questions, they are similar to last year. You may have to add a term to your ratio. So in this one, we did change it. We had to add the total column because we knew 2 to 9 to 4 is the ratio of the 3 components, the 3 things that make up the bag, which gives us a total of 15. And again, this could represent kilograms, all right, like it did in this example, or it could be bottles or pounds or whatever the particular question is focused on. So that gives us a feel for our questions involving the ratio and proportion. So if you have any troubles or difficulties, let me know, and we'll see we can sort those out.